The next up is our session on secure data science, how to detect, defend, or deter attacks to AI and data science in general. This conversation will focus on cybersecurity, misinformation, and trust, and how data science can support both privacy and protection. Moderating the session is Daniel Richman, who is the Paul J. Kellner Professor of Law. Daniel is a law professor and a former federal prosecutor who specializes in the legal and policy issues around technology and security. His experience spans everything from surveillance law to cybersecurity, making him an ideal moderator for today's session on privacy, trust, and the responsible use of data science. With that, I'll turn it over to Daniel.
Thanks. It's great to be here. Thank you for joining us. Our panel today is titled Secure Data Science, Detect, Defend, Deter. As AI and data science become more powerful and pervasive, we find ourselves at a moment that demands reflection on how we protect our systems. Cybersecurity traditionally focused on securing data, ensuring access is limited to those with appropriate activity to navigate it, and has gone beyond that to include malicious efforts against authorized persons, those in institutions like finance, healthcare, government, and individuals like bank customers. But increasingly, with systems that combine data and computing, potentially without human oversight, the old definition is no longer sufficient. On one hand, AI has amplified both the scale and sophistication of threats. We're seeing AI generating malicious code, automating phishing attacks, and creating convincing deepfakes. We also have AI models that can be tampered with, AI agents that can be hijacked, and digital systems whose decision-making we don't always fully understand. On the other hand, by working collaboratively with researchers, policymakers, and engineers, some of whom you'll hear from today, we can begin to ask whether AI can be used to design systems to defend against the very threats they help create. From a legal perspective, the proliferation of these threats presents serious challenges. Even in the old, more narrow definition of cybersecurity, we didn't come up with a very good set of legal framework. We have a hodgepodge. We have several important building blocks out there. We have tort liability frameworks. We have enforcement actions by federal agencies, often rooted in consumer protection or securities. Fraud laws, we have state-level rules that emphasize breach notification, and we have targeted federal regulations in some sectors. Broader federal regulation is not on the horizon, to put it mildly. These elements offer a foundation, though, as we build out towards a more comprehensive and cohesive approaches. Today's panel brings together experts who are exploring this evolving terrain. How data science and AI is transforming the threat landscape, how we detect and mitigate risk, and how our frameworks, technical, organizational, and legal, have to evolve in response. Our first speaker is Junfeng, professor of computer science at Columbia Engineering. His talk will explore a simple yet powerful approach to deepfake detection that uses AI to reveal the subtle fingerprints of machine-generated content, improving accuracy even across new adversary attacks. Junfeng.
Yeah. Thanks for the intro, Daniel, and welcome to Columbia Data Science Day. It's my pleasure to be here talking about our recent work on detecting AI-generated content. This is based on last year's paper published in iClear, and it's joint work with my brilliant collaborators. So generative AI is great because it massively boosts the productivity of many knowledge workers. For example, the developers, the programmers, they're using AI agents to write a lot of code. Actually, a few years ago, GitHub already published stats saying that close to 40% of the code is written by their GitHub Copilot. So that's an insane amount of code generated by AI agents. Similarly, if you look at the writers or the researchers, we're actually using these chatbots like ChatGPT or DeepSeek to bounce ideas off with each other and also write like some of the content of our papers. And also in the audio domain, there are services like 11 Labs that can take a text script and then convert that into a speech using some arbitrary voice that you can pick. For example, maybe one of the president's voices. And also many of you probably have used the notebook RAM from Google so that you can upload the paper and it turns that paper into basically a talk show. And you can listen to that podcast on the way. And also in the image and video domain, we have tools like Sora that can generate very good looking video for you. So the people in the video creation industry, like, the short video creators, or in the movie industry, they're using these tools to generate video as well, right? This sounds all great, except if you look at the bad guys, they're also using the generative AI to upgrade their arsenal and launch even like more serious, more harmful attacks. For example, in collaboration with Barracuda Networks, we studied the real emails that their customers receive, and we found that there's an uptick in the AI generation in terms of the phishing attacks, right? So that figure is a little small, but the numbers shown there is basically between 4% and 15% of emails today, like phishing emails, are generated by AI. And also, if you look at one of these serious categories of the phishing attacks called BEC, Business Email Compromise, traditionally the attackers would craft this carefully written email and send to like a CFO of a company, try to phish that per person to like wire money, right? So this is the most serious type of phishing attack. And, FBI reported that it costs the U.S. economy like tens of billions of dollars every year. And turns out 4% of such emails, like previously handwritten, now is actually generated by AI. Okay, very serious. And then if you look at that middle article, that was a New York article published last year, talking about this really bad scam imitating your loved one's voice. So some victims would receive a phone call using their children's voice or their loved ones or their siblings' voice, talking about being kidnapped and asking the victim to pay a ransom, right? So that's actually a real attack, because personally, I've known 3 people who received such phone calls. So one is a young professor in our department who received a call from her crying daughter about kidnapping, right? That's actually like a fake call, deepfake call. And also last year, CNN has an article talking about this deepfake video call, right? That conned this financial manager at a multi-nation investment bank to wire $25 million into the fraudulent's account, okay? And also last year was a bad year, it turns out, right? So there was this big Indian election, and there were a lot of election interference caused by deepfakes, generated images or videos, okay? So, these AI progresses are great, but if we don't defend against such attacks, well, like they're going to actually disrupt our social fabric, social foundation. So how can we detect such AI-generated content? Turns out there are a lot of tools, open source and commercial, out there in the market already to detect AI-generated content. But if you look a little closer, so most of these tools are basically a classifier trained on some existing data set, right? So you gather a data set of human-generated content, you gather another data set of AI-generated content, and then you try to train a binary classifier on top of that. What's the issue there? Well, typically the data distribution will shift as the attackers generate new and more content as the underlying generation technology advances, right? Such classifier will be very brittle. They'll give you a lot of false positives as the underlying data or generation technology shifts. Okay, so they're not robust. They'll give you a lot of false positives. And actually, we talked to some journalists, and they give us a lot of complaints about the existing tools. So the key question here is, how can we detect AI-generated content in a robust way? Okay. So that's basically why we created Radar, because we want to solve this AI detection problem from this first principle perspective. We want to think about what's the fundamental difference between human creation versus AI creation. You think about how today's AI generated content, well, they're going to be trained over a massive amount of data. Now, if you ask them to create some content, they basically try to look at the statistical patterns from the training data, and then they'll give you some like statistical average, right, reflecting what's in the data. That's basically the AI generation process. However, you think about how as humans generate content, we're not thinking about all the statistical pre-training data, right? We basically have our own individual creativity. We'll come up with ideas on our own, and then basically like write something that reflects our own personality, our own thoughts. Okay, so there's a whole lot of individual creativity in the human created context. So leveraging this insight, right, this fundamental difference in the content creation process, so we can actually detect the AI generation using another AI, right? So if you take the content generated, right, and then you feed to another AI editor, you ask the AI editor to help you rewrite it or transform it. And for the AI generated content for the human generated content, right? Basically, because it's created by us with our individual characteristics. So the AI will make a lot of transformations to make it conform to the statistical norm of the training data. Versus if the input data is already AI generated, right? The AI will think that, hey, this is great. The AI editor will not make many edits. Well, that's basically the fundamental insight here. We can look at the amount of edits going through an AI editor to detect what content is AI generated versus human created, okay? So that's the idea. I'm going to illustrate on that example. So here I'm going to show you two pieces of real reviews, right? One is written by a human, right? Talking about some wonderful burger that human has tried. And then, if you feed this to another AI to edit, right? Turns out the AI will rephrase it and then makes a lot of edits. Here, the red letters are the deleted letters, and the orange letters are basically the AI edit letters. You see there are a lot of changes here, okay? Versus you take some content generated by the open source model from Meta called Llama, right? So similarly talking about some review, burger, and then you pass it to a different AI editor like GPT, it's going to make very little edits, right? Here, very few letters are deleted and added, okay? So this basically tells us like the more edits you have, right, the more likely it's human generated. The less edits, the AI generation. Okay, so this is the idea from the 3,000 feet level. You guys are curious about that? Like reach out to me, we can have more discussions. Okay, so if you look at this idea, what are the advantages? Well, first of all, this is a black box. We don't require knowing the AI generation, which model used to generate the AI upfront. And also, we don't require looking at the internals like the tokenizer or all the intermediate mid-layer outputs, right? So it's purely black box. Whatever the humans perceive, we're going to use our method on the same content and tell you whether it's the AI or human generated. And because it's black box, it doesn't require all these like brittle features. It becomes very robust. And also, as you can see, we show you the things that the AI editor doesn't change. We show the things that the AI editor changes, right? Therefore, it's actually much more explainable than just a binary classifier that says yes or no for AI generation. And this also is a very general method. It works for many domains of text, right? From student homeworks to news articles, but also it works for different modality as well. It works for audio and also for video. We have follow-up work talking about that. How much time do I have?
But I have a question.
Okay. Okay.
A key question is to what extent can a malicious actor introduce human-like errors into the original?
Okay, so that's a great question, right? So basically, if you take the AI generated content, you try to like add some noise, right? Like, can you fool our detection method, right? So this is a great question. If you think about the process of adding noise, you can either do human adding noise, right? There, you're going to have a lot of effort trying to turn this AI generated content into something that's less human written. And why do you write it in the first place, by yourself, right? That's one. Two, if you think about this adding noise using like an AI, right? Turns out like once you add a little bit of noise, right, and then the rest of the content generated will fall back to statistical mean. So if you just use AI to add noise, then you detect that using AI editor, there's a very good chance that you detect that as well. And also there's this tendency of generating good content versus adding noise. And these two actually like are contradicting, as one of our papers showed. So basically, if you want to add a lot of noise, you decrease the quality, so people will be count less, right? Like the deepfake call you receive doesn't sound like a real human being that much. Okay.
All right. I want to leave room for audience questions, so we should move through. And next we have Rebecca Wright. Rebecca Wright is the Druckenmiller Professor and Chair of Computer Science and Director of the Vagelos Computational Science Center at Barnard. Her talk will examine what accountability means in computing, why it matters in the age of AI, and how it intersects and sometimes conflicts with values like privacy. That's right.
Thank you, Daniel, for the introduction. Oh, I see. This is not my slides here. Where do I see them? Okay, so good. Now I see them. Sorry, got ahead here. So all of us very familiar with today's cyber landscape and how computing has really pervaded almost everything that we do and drives advances in science and across all fields, including through the use of AI. And this is really, just tremendous. It's wonderful advances that have lots of really useful benefits to individuals and to society, but with it, it brings a larger threat as well. And so these technologies exist in a very complex socio-technical landscape. And in terms of securing these technologies and helping people to live good and rich lives, cybersecurity approaches that are more classical and take a purely preventive approach of just trying to prevent certain unintended things or bad things from happening don't always work. And on the flip side, they can also be unnecessarily cumbersome. The idea of always trying to prevent every action outside of some specified set of actions actually can be quite costly. And so the move towards accountability, which I'll be talking to today, is motivated on both sides by the fact that these preventive approaches don't always work and that they can create a very high bar. In the context of AI, we think of responsible AI, which is not just about cybersecurity, but also about decision-making, fairness, explainability, some of the things we heard about in the last talk as well as in the keynote. And accountability is also really about understanding what does happen when things go wrong, what kind of recourse people can have. And so, for example, with self-driving cars, one of the things that makes it hard for us to be fully comfortable putting self-driving cars onto the road is some uncertainty about what happens when something goes wrong, even though things go wrong with human-driven cars all the time. So there's been a lot of calls for accountability in the computing technology space, including things around social media, as well as cryptocurrency. And more recently, we're seeing both policy and discussion around AI and accountability, things like policy out of the NTIA, as well as in the European Union, and a growing realization that accountability isn't just valuable because it protects people, but it's also valuable because it can be helpful for business and helping a business to do better. So what does accountability even mean? In the context of computing, just as elsewhere, it's not completely clear what people mean when they talk about accountability, but it's often in some ways about finding someone to blame, a person or some other entity, and ensuring consequences for people who break the rules. And it can be useful for providing punishment, or in turn, the flip side, knowing that wrongdoers will be punished, can mean that individuals and society can be protected, as well as serving as a deterrence for that undesirable behavior. And so in my research on accountability, our goal has been to change the focus from a purely preventive approach, or maybe prevention plus detection that you see in a lot of cybersecurity, to really look later in that spectrum around evidence, judgment, and those being used potentially to enable punishment, which, depending on what you mean when you think about accountability, that might be your desired end goal, or maybe it's really about having a larger ecosystem that promotes deterrence of whatever behavior we're trying as a society to avoid. And so we want to shift the focus later in the spectrum, and we also take a sort of foundational mathematical approach that allows us to reduce assumptions built into our technical definition so that we can use our definition to understand what properties might or might not actually be required. So things like identity or anonymity, closed or open systems, mediator, automated punishment. We, in our definitions, don't want to take a stance on that so that we can use the definitions to do research to understand where the realm of possibility lies. So we've been working on this line of research for quite some time, promoting accountability as a useful paradigm shift from approaches based solely on prevention. And this has been an issue, not just with the examples that I showed, but even since the early days of spam and peer-to-peer systems, continues today in many forms, such as those that I showed. And one particular area we've been particularly excited to look at is identity, and understanding whether the only route to accountability is through having an understanding of the identities of who is engaged in activities at all times. And without proper definitions, we can't even hope to answer such a question. So there's a lot of related properties that one might think about or talk about when talking about accountability. And again, our work can help try to explicate and understand some of the relationships between these concepts. So our research agenda includes this formalization of accountability and related concepts with the goal of then using the ideas to actually study accountability in systems to provide improved methods and tools to understand trade-offs or impossibility results about whether you can achieve multiple desired properties, including accountability together, and then this focus on identity as a particular example. And then also thinking about the role of public policy and how this kind of understanding can help encourage this responsible technology ecosystem to protect both individuals and society while also enabling innovation. And so turning again to this question of identifiability, a concrete research question that motivated our work was, is it possible to have accountability without identifiability? And so this turns out to be quite related to the notion of open systems versus closed systems, which I won't go into in the interest of time, but many systems are actually somewhere in between, open more being about anyone can participate at any time, closed a little more rigid. And so turning that into a slightly more concrete research question, it then becomes in, for example, open systems with mediated punishment, are accountability and anonymity compatible? The answer is it depends, but before you can even answer it, you have to actually do the work of defining these things, building sort of the right mathematical formulations to let you answer. So this theorem also says it depends, but it does it in a much more concrete way. And in particular says what would be the requirements on such a system in order to be able to provide accountability without identification. So the future directions are to, and of course I haven't told you everything we've done so far, but to continue refining and applying this model, including use it to actually guide system and policy design, things like combating disinformation in social media, things like understanding implications of AI and things like deepfakes, as well as continuing to explore these conceptual relationships and then thinking about how we can harmonize both public policy and these tech-based systems and definitions to encourage that responsible technology ecosystem. Thank you.
Thanks. I'll ask one question. I think we have to have one question. So I'm pretty sure we're not going to put devices behind bars. If we can't identify or don't want to identify the nature of the threat, could you give us a rough sense of what unaccountability might look like?
Yeah. So one example of a system that sort of provides its own accountability is in the space of auctions. Often we use second price auctions. So everyone, in an auction, you all say how much you're willing to pay for something, and then the highest bidder gets the thing. It turns out that if you use the highest bidder's bid as the price, that encourages people to not actually bid their true values. If you use the second price, it turns out to encourage people to put in their true values. And so that's an example where you can design a system that sort of inherently provides some accountability. If someone says they actually want it for a higher price, there's a chance they end up paying that higher price. And so you can think about, if you don't want accountability, you can think about trying to embed things like that into how a system is even designed so that misbehaving can only hurt you rather than help you.
Thank you. Our last speaker is Jason Healey. He's Senior Research Scholar at the School of International and Public Affairs. His talk introduces a new framework for measuring cybersecurity progress, helping defenders make sense of ambiguous data and assess whether the balance is truly shifting in their favor.
Hey, thank you. Welcome. Hey, Data Science Day. Great to see everyone. Jason Healey. And we're going to be talking about the application of data to policy for my area, which is cybersecurity. Because our problem in cybersecurity isn't having data. It isn't having metrics. We're surrounded by it. Every day we're getting new headlines, new reports coming out with data. Our problem on the policy side has been knowing what to do with all of the data that's generated to try and figure out how are we actually doing and if we're actually succeeding in our jobs as cyber defenders. So the way that we framed this is defense winning? Are we shifting the advantages from the cyber attacker towards the cyber defenders every day, every month, every week, every year, every decade. Because we have these trends going back to the 1970s, literally 1970, saying that we can't secure computer systems in an open environment. And we can't say much better now, 55 years later, if we're succeeding at that. So what indicators what we have out of this universe of data that's getting reported, how can we know and answer this particular question? And again, I'm mostly looking at it from a policy question, but of course it matters in many areas. So many of the metrics we have are useless, or nearly so. How many scans are we seeing? It doesn't help us very much. A lot of others are looking at outcomes. What's our cybersecurity spend? How many open cybersecurity jobs we have? These are useful, but again, don't help us answer the question. A lot of the metrics are optimized for the enterprise, for the chief information security officer, for the woman that has the checkbook and has to decide what technology we're going to buy to help protect my organization. Again, it doesn't help us. There are a few that are perfect. I'll get to that, but there's a very few of them, and we've never identified why they're perfect. And a lot are really close, but they're reported as one-offs, not as time series, for example. And most importantly, we haven't on the policy side gone to the people producing the metrics and say, here's a framework, here's a way of putting all of this together so that we can make sense of what you're doing. So one way we can do that is to look across threat, vulnerability, and impact, which are our standard categories. And say, if on one side we have the defense is absolutely winning, and on the other side we have the attackers absolutely winning, we have that as a spectrum, what might be indicators or categories of indicators within those? Now, I'm not going to go through all of these. We're still developing this work here at Columbia, but I'll dive into one in particular where we think the logic and the data are starting to shape up nicely, and that's on threat. So if we're succeeding as defenders in disrupting adversaries in what they do, broadly disrupting, I don't just mean getting out and punching them or arresting them, but if we're frustrating what they want to do through our defenses, what would we expect to see? And we laid these out as propositions. So I know this isn't a very high-end, we have a lot of folks that don't study cybersecurity. I won't get too deep. But if we're succeeding as defenders, then we would expect the adversaries to have to shift how they attack us. Imagine bank robbing, right? If we're doing a really good job of stopping bank robbers, they have to have increasingly complex schemes. The way they robbed the bank last month has to be different from how they rob a bank next month because we're closing down avenues for them to rob banks. The tools they use, they've got to keep changing these. The vulnerability in the banks that we had last month are going to be different than the ones they have next month. These are all, like the analogy works for cybersecurity. As well as one that's really important for us in cybersecurity is the mean time to detect. If an adversary gets in our systems, what's the average time that it takes us to find them and how long it takes to eject them? So this is what I mean by propositions, right? We start laying these together as a set of logical propositions and something that had been hanging out there as a naked data point. We can now put it in and understand it better. We also do the same thing for threat actor ecosystem and organizations. Like, are there a lot of excess profits? Are we driving groups out of business? Are we shifting the problem of having enough staff and enough people around, shifting the problem from it being the defenders to putting it on them? Now, a lot of these might be really hard. It might be really difficult to detect excess profits in the cybercrime economy. But a lot of these threat indicators we actually have been collecting for years. We just haven't recognized their importance. For example, my example of shifting the tactics, techniques, procedures, like how they rob banks. We want them to shift from the easier ones, stealing your login information and then using it at the bank, and forcing them to hack, because that's more expensive and it's more time consuming. And that's exactly what we've been seeing in the data. This is data by the Verizon Data Breach Investigations Report. We've been shifting from the easier to the harder. The mean time to detect has been shifting. It used to take us hundreds of days to catch adversaries in our systems. Now it's down to about 10 days. And what I love, this isn't just from one source of data. We have this from at least 3 different companies that are reporting from 3 different data sources using different methodologies. And so while I can't look at the underlying data myself, I can have good understanding that it's probably in the range of accurate. We've done this for impact as well. I won't cut into these, but this is looking at how many overall incidents we're having, what are the monetary losses, are we seeing fewer overall incidents? And so the goals of our project are first to start laying out what's the outline of this catalog. We then want to work with the data providers to start putting together and getting into, when they report this data, that they're saying this is threat actor operations, so that those of us who are doing the analysis find it a lot much simpler. And then over time, it would be nice to shift from just measuring this to measuring against goals, where we say, great, mean time to detect, we've got it down to 10 days. Wouldn't it be great if we get it down to 2 days? And that can almost be a political goal. So with that, thank you very much.
Can I ask one
Well, yeah.
question?
Shall I take a seat? Or?
Yeah, please. So I guess my first question is, what if we decide we're improving but still kind of losing? Would we do anything qualitatively different?
It depends on where we're losing. For example, we might be winning, and we're actually seeing this in the data from a company called Scientia, is that enterprises larger than $1 billion have seen their incidents and losses go down. Small and medium-sized enterprises have seen it go up. On one hand, we can say that's a win, for example, because the most systemically important companies, the companies that are most likely, if they fail, that are cascades across the economy, are doing better. But if for especially political reasons, for saying, okay, for the people that are most at risk, for the neighborhoods that rely on those small and medium-sized businesses, for the school districts, for the smaller hospitals, we still wouldn't find that acceptable. So what we would have to do then is just make sure that we don't lose our success with that we're doing in the billion above, and try and do that for the 100 million and below.
Enough of questions from me. I'd like to ask the audience for questions. Don't be shy.
I have a question for, I think, the last 2 speakers. How does the common man or technology laggard protect themselves from cyber threats? Like, say, is VPN even worth it, or a Tor browser? And is some company making any kind of OS that doesn't take metrics anymore?
I can take a first stab, and then you can add more. I mean, I would give 2 answers there. One, very simplistically, my key advice to sort of the less sophisticated user is use strong passwords and don't tell people, and don't reuse them across different sites, right? And so usually that means a password manager is going to be a helpful way to do it. But I think that is a basic level of security advice that puts a lot of people much more protected, especially the don't reuse passwords piece. I actually think the responsibility shouldn't rely so much on individual users. So that's the second part of my answer. I think we should be building systems and infrastructure and requiring providers to build systems and infrastructure that protect people even in the face of the attackers who are going to try to get at it. And so, I think we need to work on both, helping users to better protect themselves, but actually building better tools and incentivizing providers to hit a higher mark of security, so that that the burden doesn't lie as much on individuals. That's my answer.
And I absolutely love this last point. And a lot of our work at Columbia had on this was around what's called the New York Cyber Task Force. And we're saying, how can we shift more of these advantages from the attacker to the defender over time? What have been the innovations over the last 50 years that have done that? How can we repeat those? And I'm happy to say our ideas on our the New York Cyber Task Force made it into the White House National Cybersecurity Strategy, which came out 2 years ago, March 2023. I was my second time at the White House. I was one of the drafters of that, and it made exactly the point that Rebecca just said. We can no longer. It can't be viable that we have to suffer national security level incidents because someone clicked on the wrong link, right? So we have to shift their burden of responsibilities from the most vulnerable, the least educated in cybersecurity, to those that have the power to do this. And the larger companies, through looking at, can we look at liability for software manufacturers? Can we shift to memory safe languages? Can we do things that just remove that burden from the end user instead of always constantly blaming them when things go wrong, calling it human in error because someone clicked on a link, instead of a crappily architected system that shifts that to the person at the end. So, and I might even put AI, like you Copilot and other ways to code more securely so that we can take out some of these vulnerabilities. Thanks for the great question.
Also, would users going back to, say, print media slow down disinformation or doublespeak?
Oh. It would, but it hits me in so many areas for cybersecurity. We have great ideas of how we might have a more secure internet. We just haven't figured out how to get people to buy it. And I think the same as that. Print might be good. Print had its own issues and misinformation, but the acceleration was a lot more slow. So it might be successful, but I don't see how we actually would ever make that happen.
I would say you could maybe hope to take some of the ideas. So what is one of the reasons that print media was less subject to misinformation, disinformation? It's that it's a slower process. And so thinking about, are there ways through, whether it's education to individuals or the way, again, I would argue the way the system's designed, just to have a little bit of slowdown to, do some stop and think, do some checking. And so again, it might be an individual, but it might be that that in, say, a social media system, when information is traveling too fast, the system actually throttles it to do a little bit of extra checking, because we know that inflammatory content, false content, emotional content tends to move faster and farther than sort of more rational and thoughtful content.
Sorry.
Actually, I have two different unrelated questions. For the first speaker regarding the radar technology, I'm an associate editor for several journals, and the concept of generative AI articles being submitted, and not only that, the reviews are generative AI rather than reviewer. I was wondering what you see as the role of this technology and how advanced is it to actually help journals to detect this. And for my second question, unrelated, for the second speaker, I was wondering how you deal with the issue of attribution. If you have an AI technologist generate something, and there's down the road there's a bad result. Now, is it the company that generated, the company that bought it, the person who used it? How do you deal with the issue of attribution?
So the first question is, the journalists, right? They'll write the article using AI, and then maybe the reviews are generated by AI. How do I see that? So I think the generation technology today are basically a neutral technology that can be used for good purposes and bad purposes. And if a journalist actually generates an article using AI, as long as the journal discloses that tag, this is AI generated, right? And then when the reader read that article, they understand this is AI generated. Maybe they'll put on some more alert, right? I think that's actually okay with me. So I think the important thing is a disclosure. That's why I think the technology here, right? Basically, what I talk about is you can give us a piece of content that can help you detect whether it's AI generated or not. And then if you look at sort of the research field, right, like a lot of people are writing research papers, right, and there are also conference reviews, paper reviews as well. So there, the typical protocol is you can basically generate your own draft, right? You can write the initial ideas, and then you can use AI for polishing the grammar, figuring out how to make something more concise. And that's typically are allowed by the program committees, organizers of the conferences. And also, if you look at the educational field, right, some instructors have these requirements on, hey, look, you cannot use AI, but some other instructors say, as long as you tell us, you credit the source, that's fine with us. Right, I think that to summarize, I feel that the generation technology itself is neutral. The important thing is to have the disclosure.
Yeah, and I'll actually relate my answer to your second question to this first question in this example. So I think in this question of attribution is certainly an important one, and in many real world settings, it's going to be a complex one because there's not one specific action. There may be many actions taken together, and so what would be required to actually get to the accountability that we would be seeking is you would have to build a little bit more up around it to make that possible. possible. So you might have to have policies that say some of these things about what is allowed and not allowed in, for example, the use of generative AI in writing papers and writing reviews. What is the process in vetting papers and reviews to actually accept them and publish them? So if your policy was we don't want to publish certain kinds of articles that haven't had a certain proper vetting process, then maybe also you need this detection or tagging required to say this is the ways in which generative AI was used in creating this article. This is the ways it was used or not used in creating this review. This is the decision-making process. And so that later, if it's found that an article that shouldn't have been published was published, you can actually go back and look at the record. But in fact, it shouldn't even get to the point of being published because the tools actually tell you this is not a publishable article according to our policy. So that would be one example. But definitely you need to think about sort of causality and hope to tease out what the contributing factors are and put in more processes, more protocols, both in the technology and perhaps in whatever legal regime or policy regime sits around that if you actually want to get to the possibility of taking the right kinds of actions when something does go wrong.
Sure.
So one question for the first speaker. So wonder what's the next step for to promote your techniques. Have you considered collaborate with some open source libraries to integrate with your technique?
Great question. So of course, we're interested in open sourcing our technology. Right now, there's some future research problems that we're working on. So the important thing about detecting deepfake, especially for like journalists, is to have this really good explanation about which part of the image is fake, right? Or video is fake, which part is real. So we're actually working on making our technology more explainable, leveraging the latest large vision and language models, right? So these models, they understand both video and also languages, the text part. You can actually ask these models to articulate the things that are changed by the AI editor, right? So that's one thing that we're working on. But we're actually looking for partners to take our technology to the next step. It could be, like users of the technology. It could also be some commercial partners who are interested in doing startups. We're happy to license technology out.
Yes, thanks.
Just following on that question, have there been any efforts to democratize what you're doing to the individual level to offer individual identity protection? And are there examples of companies that are doing that? Can your technology be used for that purpose?
Good question. So there are certainly startups doing these kind of AI content detection. So there's like there's GBD0. I think that came out of Princeton, right? So basically now they're like a startup. They received funding, so they basically help the professors detect whether students cheated in their like writing assignments, right? So you have such companies. So we talked to some journalists at the AP, and our the feedback we got is so number one, that there's like a lot of the robustness issues, as I mentioned in my talk. Number two, if you look at the other modalities like image, video, and audio, right, they become like even more challenging to detect correctly, and there are a lot of false alarms. So I think the like my issue is so how to make the detection really robust, right? So that's why I feel like our technology can add to what's in the market. That's the first thing. And second thing, you're talking about how to bring this into the hands of all people, right? So that's a great question. So here, in order to do the detection, right, like we need to have some GPU compute, right, to like run these model inferences. So that's actually like a cost barrier, right? So if you want to like make this a service for many people, I think that we have to pursue this commercialization path, right? So if you're interested, happy to brainstorm afterwards to figure out how to commercialize this.
Last question.
Hi, I'm Bagua from Stevenson 2 across the river. I just had a question for Professor Yang. What ethical considerations should we consider when we have the applications that you mentioned across video, text generation, and audio generation?
You're asking about the ethical considerations?
Right.
Okay. So, this goes back to the question asked by that gentleman over there. So I think the disclosure is very important, right? Like I view this generative technology as a neutral technology that can be really powerful, empowers all the knowledge workers, but also the bad guys can use that as well. Right? I feel like, we need some way to figure out if I'm seeing this content, I'm consuming this like article, I'm listening to this particular phone call, right? Like which part of it was generated by AI, which part was not, right? That I think that's like important, so that individually or at the organization level we can create a policy or we can make our own decisions, right? So I think this is a good point. And I also want to mention that there's this authoritative effort people are working on to use so-called watermarks, right, to basically add to the generated content, right? For example, the model builders like Google, Meta or OpenAI, right? They can, when their model generates a piece of content, you can actually planting some of these marks that humans wouldn't notice, but you can detect that using machine, right? That's like an authoritative effort, right? Basically, these content creators or the model builder, they can opt in to do that, and then later you can detect whether this piece of content is AI generated or not, right? That's actually orthogonal to the AI detection, because what we talked about here is more like assuming the adversarial setting where the attacker created the content, or they may have trained the model, so therefore they're not putting in the watermarks, right? I feel like this is another technique, right, that probably like goes back to the ethical question you asked. If the good companies, they put in the watermarks, right, that will provide like some orthogonal solutions, right? Yeah.
The mark of a successful panel is their questions that we go unanswered. So I'd like to thank this panel for a fantastic panel.
Yeah, thank you, Daniel.